All right. 4-6. Solving quadratics using the quadratic formula. Okay, we're going to kind of skip over this. Basically, not every method works that we've done so far every time. So the quadratic formula works every time. Okay, no matter what, this will always work. All right. Probably remember this from Algebra 1. This is the day your teacher sang. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Sticks in your head. It's annoying, but it's a good way to remember it. All right. So, also important, just as before we've done, standard form has to be equal to 0 first. All right. So, I highly suggest you get in the habit of doing this, just labeling or off to the side or both. So A equals 3. Be careful, B is negative 2. Very common mistake there is to just say 2. And C is 4. Now, since there are negatives in this formula, I suggest you write out the formula first without any letters. So X equals the opposite of B plus or minus the square root of b squared minus 4ac all over 2a. I did not mean to write the a. All right? And then fill in your numbers. Now, the reason I say to do this is because here is where most of the mistakes happen, especially when b is a negative number. Okay? Often, don't write this down. Here's what people will do. I'm not going to do the whole thing. They'll do this. Oh, x equals opposite of b. Oh, it's already negative 2, plus or minus, and then they go on. And that's a problem. Okay? Because in this case, the opposite of b, which is a negative, will end up being a positive. So pay attention whenever you're filling in a negative b. All right? B squared, negative 2 squared, minus 4ac all over 2a. Now, the second place that people make a mistake is right here. Okay? Even though, as we talked about this before, everyone knows that a negative times a negative is a positive, this is what happens. They go into their calculator and they go negative 2 squared. And they say, oh, it's negative 4. The calculator is not wrong. It is true. Because what this is saying is the opposite of 2 squared, as opposed to this is what you really are doing. And you get a positive 4. All right? So there's a few things you can do. One, just always remember that it should be positive. So if the calculator says negative, just be smarter than the calculator. 2, use parentheses. Or 3, just put it as a positive because it's going to end up being positive anyway. Only when you're squaring. All right? So next we do x equals, the opposite of negative 2 is 2, plus or minus 2 squared is 4, minus 4 times 3 is 12. 12 times 4 is 48. All over 6. So that gets me to x equals 2, and just step by step. This is long, but it's really easy. It's just number crunching. Negative 44 over 6. Now remember, this is going to break down to 4, 11, and negative 1. All square root if you need to put that and remember that. Okay, so when you simplify that, it's going to be x equals 2 plus or minus. The square root of 4 is 2. The negative 1 comes out as an I. The 11 stays inside, all over 6. And now you have to be careful here. If this number here was like, say, an odd number, you could not just simplify that as 1/3. It has to be everything, all or nothing. So since they're all even, I can simplify this further. X equals 1 plus or minus, I can put the 1 or not, 11 over 3. But you have to do it consistently with everything. All right. This one is not set equal to 0. So I need to move this over and subtract x and then subtract 2. So I'm going to get 6x squared. 8x minus x is plus 7x. Negative 3 minus 2 is negative 5. Now that it's equal to 0, I can identify my a, my b, and my c. So a is 6, b is 7, c is negative 5. And then I just, again, whoops, got ahead of myself. Write x equals opposite of b plus or minus square root b squared minus 4ac all over 2. I don't know why I'm doing that. I did it again. 2a. And now you just fill them in. So b goes here, a, c, a. And now it's just simple number crunching. Opposite 7 is negative 7, plus or minus square root. 7 squared is 49, minus, now be careful here, minus 4 times 6, okay, is negative 24. Okay, but then negative 24 times 5, times negative 5 is going to be a positive number again. So this ends up being a plus 120 over 12. So, 120 plus 49 is 169. So I end up with a perfect square underneath my radical. Now in this case, when I end up with a perfect square, that's going to come out as a number, 13 over 12. Since I came out with a number, no radicals, no i's, I'm going to split this up into two problems. X equals negative 7 plus 13 all over 12, and negative 7 minus 13, again, all over 12. So here, 13 minus 7 is 6 over 12. This is negative 7 minus 13 is negative 20 over 12, and we always reduce. So my two answers are 1/2 and negative 4 goes into both of them. So 5 times 4, 4 times 5, my bad. And 4 times 3, negative 5/3. And if you wanted to write that as negative 1 2/3, that works too. All right, looks good, except remember, not set equal to 0, so I need to move that over first. Don't know why I made that a minus, a plus. Minus 12x, this becomes positive 6. Once I have that, A, B, C. So 4, negative 12. Remember, be careful whenever B is a negative, and C is 6. X equals the opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. And yes, I was telling myself the whole time not to write A there. Plug them in. Negative 12 here, negative 12 here. 4, 6, 4. A, C, A. Now it's just number crunching time. X equals, opposite of negative 12 is positive 12. Don't know why I wrote an equal sign again. Plus or minus. 12 squared and negative 12 squared are both 144. Again, remember, most common mistake is right here, putting negative 144. Minus, okay, it's going to be a minus because you got minus 4 times 4 is negative 16. And then negative 16 times 6 is 96 all over 8. Now, 144 minus 96 is 48. So we end up with x equals 12 plus or minus 48, not negative, 48, all over 8. This is going to break down. Now, 4 does go into it, but it's not the best number. We want to use 16 times 3. We want to use the biggest number possible. So that gives me x equals 12 plus or minus, the square root of 16 is 4, root 3 stays, all over 8. Now, once again, 12, 4, and 8 all have a common factor of 2. So I can reduce all of these dividing by 2. So 6, I'm sorry, I meant 4. They do have 2, but we want 4 because it's best. So 12 divided by 4 is 3, plus or minus 1, root 3. And if you just want to write root 3, you're fine, over 2. All right, now the discriminant. The discriminant is the part underneath the quadratic. Just the b squared minus 4ac, not even square root, just b squared minus 4ac. It can tell you all this information. So if it's positive, that means you have 2 real solutions. In other words, you're going to end up with something like this, where there's an intersection here and intersection here, or something like this. 2 solutions. That's what it means. Because remember, a solution is the same as an x-intercept, all right? The same as a root. If it's negative, you have 2 imaginary solutions, like this, or like this, where they never touch the x-axis. And if it's 0, you have 1 real solution. So 1, it just hits and bounces off the floor, or bounces off the ceiling here. Okay? That's what the discriminant tells you. So remember, first off, we always need to have it set equal to 0. So we need to move this over. So negative 3x squared minus 7x minus 4. Right? We only have to deal with the b squared minus 4ac. B squared minus 4ac. So plug the numbers in. What are the numbers? Well, a is negative 3, b is negative 7, and c is negative 4. Negatives all over the place. So negative 7 minus 4ac. Okay, so negative 7 squared is 49. When I do a negative times negative times negative, I'm going to end up with a negative number. Okay, so 4 times 3 is 12. 12 times 4 is 48. 49 minus 48 is 1, so the value of the discriminant is 1. Okay, so when I get 1, remember, that's a positive. So I'm going to have 2 real solutions. All right, got to move this over. Remember, put it in the right place. 5x squared, minus 2x, very important, minus 2x plus 7 equals 0. A, B, C. 5, negative 2, and 7. Again, I do my b squared minus 4. There I go doing it again, writing the a in. A, C. So negative 2 goes here, 5 goes here, 7 goes here. So negative 2 squared is 4. I'm going to get a negative number. 5 times 4 is 20. 20 times 7 is 140. That gives me an overall value of negative 136 as a discriminant. That's a negative value. Okay, so a negative value is this one, where it doesn't touch the axis, no x-intercepts, so 2 imaginary or complex, either one. So yeah, I wonder what the next one's going to be. Oh, there isn't one. Well, that's a crime. If we would have had an example with 0 underneath, all right, then that would have been one solution. Okay, but that's it.